Okay, here's a short video demonstrating the Cantera combustion tool and vapor liquid tools. Let's go to apps.ignite.byu.edu, and depending on the settings you might have to go to the advanced button there, depending on the certificate settings. So we can select mechanism here. So we basically, this first screen lets us set the state of a gas. For combustion with something like methane, we'll want to use the GRI 3.0 mechanism. And then we can set the temperature, pressure, and composition of the gas, and whether that's in moles or mass. So here it's set H2 102.5 N2 1.88. Let's change that to CH4 1 022 N2 7.52. That'll be a stoichiometric methane air flame. And then this first drop down here, we can compute gas properties for that. So if we set this to be like 300, for example, and 101325, compute gas properties, then we get a little output written here, and that'll tell us the temperature, pressure, density, all these properties for that gas state. Okay, so if we were, and so you can put pretty much any gas state you want here and get those properties out. So if you're doing something like an auto cycle, you might start with air, for example, maybe stoichiometric methane air, and then you could use compression expansion relationships to find a new temperature and pressure and then get those gas properties. And then once you have those gas properties, let's suppose it was hotter, like 500 Kelvin and maybe nominally twice the pressure, then we could find those gas properties again, gas properties, and those gas properties, and query those things there. Then we could come down here and do an equilibrium. So if we wanted to burn that gas, we could burn it. And there's 4 types of equilibrium: specified temperature and pressure. So if you use this temperature and pressure, then it will equilibrate the gas at that state. So you'll get a new composition. If we do that, compute equilibrium, you can see the gas composition here changed. The temperature and pressure is still 500 and the same pressure, but the composition is different. And that composition is listed down here. If instead you say, I want it to be HP, that'll be adiabatic at constant pressure, so the temperature will change. TV is given temperature and volume, so whatever volume and temperature correspond to this state will be what's used. And then UV will be adiabatic at constant volume. So if we do 500K, 2 atmospheres roughly, and U and V, and then compute equilibrium, then we come down here. Now it's very hot, and the pressure has gone up because the volume is constant, the temperature is increased, and you can see the composition, mass fractions and mole fractions, and these other properties including gamma that's listed here. And then you could take, if you were doing an auto cycle, for instance, you could then take that state and you could run that through compression expansion, ideal gas compression expansion relations to find new temperature and pressure. You can also take this output string. The output string is listed for convenience so that you can, for example, you can copy it and paste it in here if you want to go from one state to the next, and then compute gas properties again, and it will find the properties of that gas at different temperatures and pressures. So that's a simple way to use this tool. There's other tools that you can use. Reactor calculation will run a batch reactor or a plug flow reactor or a continuous stirred tank reactor using these compositions as like initial conditions and or temperatures and then different settings here. There's also some premix flame calculations, non-premix flamelet tools, things like that. So that's a quick introduction to using that tool. There's another online tool if we go to the same site, apps.ignite.byu.edu/vapor liquid, and this will use Cantera to get properties for these different fluids. So if we look at water, you basically set two quantities and use the other blanks. So if you set the temperature and the pressure to be like 1000, compute properties, it's going to be a vapor, a gas, and with these properties. If you set instead the temperature and you set the quality to be 1, the steam quality, then it's a gas liquid mix with a vapor fraction of 1. So it's either going to be subcooled liquid, superheated gas, or a vapor liquid mix depending on what you specify here. So if you want the quality to be 50%, 0.5, run that again, it's still a gas liquid mix, but you have a different vapor fraction. And you can set various combinations of these as noted. So that's another tool that can be used.